Good morning, everyone. Welcome to DebConf 2021. My name is Fernao, and I will be presenting this talk about virtual machines with KVM, QEMU and LibVirt. Since it's a conference, Debian is a GNU Linux distribution, we're going to talk a whole bunch of free software here as well, and also we're also trying to have a little bit of fun while doing it. This presentation that was made using tools that are free, libre, and open source, mostly GIMP and LibreOffice. So that's the good part of this presentation. The bad part is the memes and the images were edited by a sysadmin myself. So a little bit about me. My name is Fernão. I'm from Curitiba, Brazil. There might be some snippets of this presentation that is still in Portuguese. My apologies for that. Anyway, I have the slides, scripts, and other materials inside repo inside Salsa. I work with. I'm a consultant of technology. I work mostly with development and hosting of sites, mostly WordPress. I'm also a teacher. I used to taught history. So this presentation is not only about technical matters. I also have some historical perspectives that I can help myself. So a bit about the topics themselves. We are going to talk about virtualization, yes. But we need to establish some initial concepts. We have to talk about semantics and terminologies and whatnot, because there's a whole literature about it, and the terminologies they're not friendly all the times. We're going to talk about architectures, mostly x86 as well. So, configuration and requirements of these hosts for the virtual machines, how to configure it and how to make them work and all that. Also, you're going to see how to manage those VMs using Gnome Boxes and the LibVirt interfaces that are VirtManager and VirtManager. This presentation is rather intended for individual users. This set of software can be used in production, in big corporations and all that. The Taipu Dam uses, the Brazilian army also uses, so it's solid. And we are going to see a little bit about how to use graphic console modes, because if you are running a virtual machine, you need be it graphical installation for Linux or other proprietary systems like Windows, you need to have a graphic console mode. We're also going to talk about snapshots and persistent storage. That's a big part of the presentation, especially the persistent storage, and network configuration as well. We're going to build bridges so we can have the virtual machines accessing the internet and talk amongst themselves. We're going to see how the firewall works, in this case IP tables based, DNS mask, network address translation, and all that. And we can we must see security, some use cases, and all that. Execution too. These topics, they are outlined here, but they are not going to be so delimited as in here. They're a little bit more fluid. We're going back and forth from different topics, and some closing words and to wrap my thoughts up, and then followed by questions and answers. We have an Etherpad link in the presentation. Feel free to leave comments, to ask questions. I'll do my best to answer them all when we have the proper time. And a little spoiler here, that we need more hardware and software that are freely open source, because since we're talking about virtual machines, we have to deal with lower levels of the software drivers closer to the hardware, and that's very complicated to deal with, because we don't know what's going on in there. And the big tech monopolies, the monopolist capitalism, the surveillance capitalism, they are part of the problem, and of course not the solution. So In this line of thought, I like to borrow this idea from Julian Assange that users must have privacy and governments and big corporations, they must have transparency, not the other way around, never the other way around. I go a little bit further here and add privacy and freedom for users, transparency and accountability for vendors, governments, the big guys. Because NSA has thought as well that the price of freedom is eternal vigilance. Yeah, that may be true, but I like to reappropriate this notion and say that the price of software freedom and data privacy is eternal vigilance, because it's a daily battle, it's an uphill battle, and it must be done daily on a daily basis. Even though we know that systems they can be secure, they are secure if they are libre, because if the password is not known, and everything about it is public knowledge, well, the system has to be secure. That's a very old notion from the 19th century that this guy August Kerckhoffs, he wrote a whole bunch of works about cryptography. He was, of course, talking about letters and the telegraph and the booming telecommunications in the 19th century. But that principle, it can be applied, it must be applied to computing nowadays, and a system that that is composed by free software and has distant cryptography, it falls into this principle with no problem at all. Anyway, all of this, it's rather for educational and academic purposes. It comes with no warranty. If you're going to try to do it at home, you must be aware of the risks, and a little bit of red pill will never hurt anyone. So we are talking about virtualization, but emulation and simulation, they may be treated as interchangeable synonyms, but it's a little bit more tricky than that. So when I'm talking about a virtual machine, I'm talking about a full computer, a Turing machine, CPU, RAM, the whole 9 yards. It's a simulated computer inside another computer, and it can use hardware as if it was a native system. We can think about virtual machines in the context, for example, the Java virtual machine or Citrix and all that. But they fall into application category. What I'm interested here is more operational systems virtualization. I'm also going to talk pretty much all about the x86 hardwares, be it 32-bit, 64-bit, because RAM hardware, it can be virtualized, yes, but it's rather recent architecture and I'm not too familiar with it. So what does a VM has to do with an airplane simulator, a video game emulator, if anything at all? Well, let's start with the mainframes, because the mainframes, the virtual machine, the initial concepts of virtual machines in the 60s and 70s, it came from mainframes, because mainframes they were large, expensive pieces of hardware that could execute only one task at a time. Most of the time the hardware was left idle, and there was no way, no feasible way to have to use it in other ways rather than the single execution environment. So the virtual machine, it's at its core, it's an idea that comes from mainframes. The video game emulators. Well, video games, they are computers in themselves, but they are, yes, 16-bit or 8-bit, but they are not virtualized, because this emulation is done in an application level. The video game, it's not. It doesn't have access to the hardware. Whatever you use as an input, the joystick or keyboard, it's not like the physical one, so it works differently in its inner workings. And lastly, the airplane simulator. Well, let's think about what is it. We have the real situation of an airplane, and we have something that is simulated in more controlled situations. Less airplanes will fall given the situation. It's easier to teach people how to fly and all that. So the simulator seems, in my opinion, is something that's rather a situation from the real world that's brought to a computer. So, but if you think about it, we are simulating machines inside other machines, so they are close in terms of semantics. In the end, they are all methodologies for better sharing resources from either hardware or software, and it allows the creation of distinct and multiple software execution environments inside a single physical host. So we have this notebook of ours, we have the desktops and whatever. This presentation, by the way, is rather intended for this individual user, this Linux user, but someone who is interested in using virtual machines to discover Linux and all that. But we have this single physical host that is our notebook, so to speak. And we are able to run not only our operational system, but we can emulate video games, we can run Java, and of course emulate other operational systems inside this one single host. So in order to do that, we need a monitor for all these virtual machines that's called the hypervisor. It's also known as virtualizer, but I like better the term hypervisor, because the kernels, the system kernel, it's reference, it's known also as the supervisor. So if we're talking about the supervisor of all supervisors, it becomes the hypervisor. If this was the Lord of the Rings, one ring to rule them all, or the I capo di tutti capi. So these guest systems, they can be of pretty much any type we think about it. So when we talk about hypervisors, there is this one known as the bare metal. It's a system. It's a system that doesn't do much more than managing the hardware, and it also allows the creation of other operational systems. The reason I put this asterisk here is that the hypervisor in itself, it's composed by these two parts. We need to have a special machine. If it's a Zen architecture, it will be the DOM0 and all that. So this machine, it must be configured. It's a special machine that's used for managing the whole infrastructure. So this is not what we're going to talk about here, because KVM it's a different kind of hypervisor. It's a bit tricky here. Because the KVM in itself, it's actually a type 1 hypervisor, but conceptually, in terms of architecture, it's rather easier to think of them as this operating system at the base managing the hardware. Then we have the hypervisor. Oh, damn it! We have the hypervisor here that manages all the virtual machines. In terms of architecture, the KVM, VirtualBox, Beehive, it's from BSD. They are all similar for that matter, and they can have all this, a whole legion of systems on top of them. So another important concept here is the paravirtualization. The paravirtualization, PV for short, it's not full virtualization, because we have systems that are distinct, but they are still sharing resources from the host, the kernel, the memory, and all that. It's not fully isolated. So when we have full virtualization, that's when we have separate and distinct operating systems, and the host and the guests, they are fully isolated. I put another asterisk here. We're going to talk about it in a minute. So this was the real game changer, because virtualization and emulation and all that, it's as old as the mainframes, but the performance of doing that kind of emulation from non-native systems, the performance was terrible, it was frustrating, it was terrible. So around 2005, both Intel and AMD, they started to launching CPUs that have this virtualization extensions. They were a set of instructions that make the job easier for achieving full memory isolation, the CPU emulation, and all that. These extensions, they must be enabled on the host BIOS before we start to run virtual machines. Any hardware that's less than 10 years of age, it should have these virtualization extensions. The problem here is that yes, we have full memory isolations, but as everything in IT, that virtualization, it relies on layers of abstractions. It may leak. Spolsky's law, it was named after Joe Spolsky. It was the founder of Stack Exchange. He conceived the notion that all abstractions that are non-trivial, they are bound to fail at some point, because they assume some predictability that cannot be guaranteed. The example he gives, it's TCP, it's the network protocol TCP over IP. Protocol TCP is a trustworthy way of delivering information, but the IP is not as reliable in terms of that. So that conflict, they might generate leakages that might present security issues. Virtual machines, they are vulnerable to issues like spectre and meltdown. For anyone who likes to know more about this, there is the works of the professor Alexandre Oliva. He is one of the responsibles for the Libre Linux kernel. So most of his works are in Portuguese, I suppose, but he probably has some works in English as well. So hypervisors, they are made of layers just like onions and ogres, and they can make us cry like onions and ogres. The hypervisor, it can be hijacked. That's why it's called hyperjacking, because we have this hypervisor that it controls the hardware, it controls the virtual machines. So if you hijack it, you control the whole of structure. Remember, one ring to rule them all. If you control this one ring, you control all the others. So that's one problem of one security problem. And the other reason we might cry is because of the lack of transparency of the blobs and the lower levels of software and hardware, because that is very opaque. Let's think about this drawing. Here we have us, the individual users. We have our notebooks, we have our cell phones, and all of our data, it comes and goes from this router that is controlled by the ISP. So what I'm proposing here is that users, they have to be, most unfortunately, they have to be an army of one person. And we have to understand of notebooks, we have and x86 architectures. We have to understand about mobile. We have to understand about embedded. It's like if we're thinking about armed forces, we can think of ground forces, navy, and air force. So even these two guys here, they are very important, because all of the data, doesn't matter how many other devices you have, all of them, they are going to pass here at some point. And even if you establish connections to a VPN or to a Tor node, you are still subject to interception. So it doesn't matter if you have all the security in the world here, but the other parts of the equation, they are somewhat compromised. So we have many systemic risks that we need to mitigate here in rather broad terms. I'm going to take a small detour from the inner layers of virtual machines and talk about the outer layers of this architecture. So you have to think about the hardware and software that are non-libre. We have to be worried about the abandoned IoTs, IP cameras, smart lamps, the whole bunch of crap that is pushed to consumers nowadays. And the problem here is that the vendors, they don't have accountability. They are not forced to keep shipping updates. So it becomes abandoned system that it becomes eventually vulnerable to exploitation. So we have adwares and rootkits as well, because adwares being malicious software that displays us advertisement that we are not interested into, be it from Google or whatnot. And we have rootkits, we have DNS interception. And we have closed source systems like Google, like Windows, like Google services. We have Siri, we have Alexa, and finally we have Mirai and Pegasus. If this looks like the lineup of a football team, yeah, that's I started listing the things and it pretty much drew it by itself. So it's a cute nickname that I gave to it. It's the Ransomware United. Ransomware because what unites them, what they have in common is that they hijack, they keep their users locked into walled gardens, and the coach. I told you guys that this means coach, and this means internal network, local network. So why I chose Larry Ellison and Eric Schmidt to be the coach and the CEO of this Ransomware United team? Well, that's what the reason is that Larry Ellison, he's the owner and CEO of Oracle, and he's Oracle is the owner of VirtualBox, so it does have a lot of context here since we're talking about virtual machines. And the whole idea of using KVM, QEMU and LibVirt is to get rid of VirtualBox and other VMware and other closed source solutions. And he also is from the Republican Party in the United States, and he's a big donor for Republican candidates, but no one sees anything weird about a billionaire from technology financing campaigns. But if he was Chinese, well, that would be something else, or if he was Russian, or who knows. But since he's an American, there's no problem at all. Eric Schmidt is the same thing, but he's a Democrat. While he was a CEO of Google, he was one of the responsible. He was doing back-channel talks to Cuba about ending the embargo in 2014-15. He also interviewed Julian Assange as an emissary from the State Department. That became the book when Google met WikiLeaks. But the real fun here is that he conceived business plans that according to his own words, emails, users that use Gmail, they can't have a reasonable expectation of privacy. Well, I think that's quite problematic. And he also likes to make his business his business workings to get to the line of creepy, but never crossing that line of creepiness. But he's always close, and what he considers creepy, what he doesn't consider creepy, other people like me might consider creepy, so we have a problem here. So that's why. We can also put this in terms of a meme, because you can have a whole bunch of free software that they perform better than their privative, their proprietary counterparts here. And we must think of them as the rule, they must be deployed by default. Their free software, it's not an alternative to proprietary solutions. We must change this mindset. It's terrible, because we always say, we have LibreOffice, that's a good alternative to Microsoft Office. No, it's the other way around. Microsoft Office, it's a worse alternative than LibreOffice. It's not that LibreOffice is an alternative. Microsoft Office is an alternative to LibreOffice, and it's a worse alternative. Or in the words of the Rolling Stones drummer that sadly is deceased in the last few days, "I'm not your drummer, you are my singer." He said that after he punched Mick Jagger in the face. Well, they were in a tour, Mick Jagger got drunk, got sentimental, and then he called Charlie Watts, "Where's my drummer? I want my drummer," in the middle of the night. So Charlie Watts, he got dressed, and he went to meet Mick Jagger, he punched him in the face and said this famous phrase, "I'm not your drummer, you are my singer, never call me your drummer again." With the possible exception of the punching people in the face, we must think about like that when it comes to free software and their privative counterparts. Because be it free software or not, business plans they are neutral. They do not happen in a vacuum. They are part of something bigger. That's talking about the invisible hand of the market, like the Adam Smith used to say. Well, this invisible hand of the markets, it's very well articulated with the strong arm of the state. So that's why we have this revolving door between the public sphere and the high echelons of big corporations. They take political decisions. Their decisions, they are ideological as well. It's not just something from our side. And those plans, they are predatory in their nature, and they are so because of their actions of their leaders. Let's talk about Elon Musk. Elon Musk is quite a pop star, but he's saying that he will do coup d'état, puts or depose elected governments whenever he likes, whenever he feels like, whenever he has a government like Bolivia that threatens his access to lithium. So that's pretty much capitalism in its rawest form. So that same Elon Musk from the same Tesla company, he also opened all of their patents in 2014. That's an example that should be followed by other industries. And Elon Musk, I'm not a big fan of Elon Musk, not at all. But here we always had billionaires that do interferences in Latin American countries. But at least Elon Musk is not only producing electrical cars to replace cars run with gasoline, but he also adopting this posture of opening his own patents, because if you come to think, most of the problems that we have in technology, in computers, in systems and all that, they do have a root cause in some problem for patents. Cryptography was a big problem because of export controls and intellectual property. If you think about storage in the Android environment, we have the Android uses XT4, but its SD card must be formatted. The VFAT, the FAT systems, the XT-FAT and all that patents that belong to Microsoft, they hinder the progress. They are still a pain in the ass these days. So these patents, they are in what you use in our systems, it's the libraries, it's the everything. So when we have cryptography combined with layer defense and free software, this is efficient approach to security, and it's also something that it's at disposal of individual users. And if you have less protectionism about intellectual properties, the users could be better served. And when we talk about cryptography, we must talk about this guy, Edward Snowden, and about the vigilantism from NSA and all that. Because NSA, it's behind cryptographic patterns. It also has a long track history of tampering with these cryptographic patterns. And the big tech, they always like to sell this idea that they are independent from the government. But when push comes to shove, the big tech, it will fall in line and will follow the government orders, whichever it is. And in 2021, he used this meme to troll the big tech, Apple, most notably, while he still deplored the vigilantism from the Israeli company NSO. Pegasus is it's a problematic system. NSO approach to selling the software is complicated, and what the critique that Snowden did, it's very pertinent, because export controls, we can only trust the words and intentions of capitalistic companies, because they will sell their software to the highest bidder, and no matter what they say about we're only going to sell it to governments, to legitimate governments that have a good track history of human rights. They don't abuse human rights. Yeah, and then they go on and sell to Saudi Arabia. Nice. So just like vaccines, encryption works. Don't let them convince you otherwise. And it's a far too important subject to be left in the hands of the bureaucrats, unelected bureaucrats most of the time, and billionaire corporations. Here I made a note about how the PFX patterns that were developed by Microsoft, they are the antithesis of how it should be done. So it's very interesting. It's a quite short read. Anyway, so because when you left these things to billionaire corporations and bureaucrats, they start to come in with these not so funny ideas of secure encryption with backdoors. It doesn't exist. A secure encryption with backdoor is just like a woman being half pregnant. It doesn't exist. It doesn't happen in real life. Either a woman is pregnant or she's not pregnant. End of story. Either the encryption works or the encryption doesn't work. If the encryption can be broken with more than one key, it doesn't work, so it has a backdoor. So it's a ridiculous idea that we should fight against this notion. And we have this very famous cartoon from XKCD that it points to a complicated issue, that it doesn't matter, cryptography won't protect you from torture and human rights abuses and all that. So, but anyway, when we don't have violence on your side, cryptography should work. Except when it's rigged, except when it's tampered. And that's what a Swiss company called Crypto AG did from the 1960s until a few years ago. They used to sell encryption gear to third world countries like Brazil, like Argentina, like Iran, like Egypt, like a whole bunch of countries. And they made it readable to the espionage apparat from the United States and then West Germany. For people who are younger, Germany used to be divided, Cold War and all that. So we are talking about the capitalist Germany, and it's interesting to notice that this sting, it's we have the collaboration of Siemens. It's received part of a percentage of the profits in exchange to make believe that he was the controller of Crypto AG. So we must question in times of disputes around the telecommunications future, the 5G and all that. We are blasting Huawei because of their ties with the Chinese government, with the Chinese military, but we must question as well what are the links between Siemens and Cisco and Ericsson and all the other companies that are participating in that, because the vigilantism from Europeans or from Americans, it's not better, it's not beneficial in any way other than Russian or Chinese. That's a notion that should be fought as well. As a Brazilian, I think it's quite worrisome that the Brazilian government is considering banning Huawei and buying equipment from either Siemens or Cisco or whoever who is not Huawei, because Siemens and Cisco, they have, it's historical fact, they sabotage the equipment, they sell equipment with backdoors to us, and they get away with it. I'm not trying to defend Huawei at all here, because Huawei, it must be questioned, because what I know from their software, their build system is very questionable, because their systems in this decade, they still use Linux kernel 2.6, they use outdated components like UPnP, like DNS mask, like all components inside routers and all that. Their software is crappy, and they admitted that they copied from Cisco. It seems that they didn't update it since they copied. So Adi Shamir is the S in RSA, the cryptographic pattern, and he always say that typically cryptography is circumvented, not broken. Yeah, that's true, because whenever you have a bolt, lock, padlock or something in a door, you're not going to try and break it. You're going to have too much hassle. Instead, it's much more easy. It's easier to look elsewhere, to look for a window, to look for an exploit through a crack on the wall or anything else. So we circumvent cryptography. We don't actually break it. And it was very interesting to see the feud between the Signal founder and the Israeli company Cellebrite, because Cellebrite allegedly claimed that to have broken the cryptography from Signal, and then the Signal team started to poke around the Cellebrite software and discovered a whole bunch of vulnerabilities in there. It was quite funny to watch. So I'm ending this cryptography part here, and now I'm going to talk about other part of the security landscape. We can say that we have malware as a service these days, because we have, besides ransomware, we have news outlets that have Bleeping Computer, more specifically. It has a column that's called "This Week in Ransomware." It's quite telling. And ransomware, it's the irrefutable proof that cryptography actually works. So we have also botnets. I mentioned in the lineup both Pegasus and Mirai. Mirai is a malware that infects mostly routers and IP cameras. It builds botnets that can be used to deploy DDoS attacks. So whenever we hear about Cloudflare suffered an attack and half the internet went down, DNS suffered a DDoS attack, half the internet went down. Normally, typically, it will be a Mirai botnet that caused it. There are some opportunistic infections like the VPN filter. VPN filter, besides the horrible name for a malware, it's interesting to observe that it works a little bit like immunodeficiency syndrome, like HIV virus, because the router is infected but is not actually doing anything. It hasn't contacted the mothership, but so it can deploy the second phase of the malware. But the infection is still there, and unless we update the firmware, we can have it. It will remain there indefinitely. We have also supply chain attacks like the SolarWinds incidents. The Sunburst was one of the names of the vulnerabilities. Supply chain attacks, they are really, really, really worrisome, because, well, whoever worked with software packaging, with firmware builds, all that, be it for embedded system or for mobile, it's huge infrastructure. It's impossible to keep track of what's in there. We can never be too sure that it's actually clean. It's not as easy to audit as source code. It takes a lot of work, and that's the problem, because if you infect the supply chain, if you infect the build system, if you infect the compiler, you are controlling that pipeline, and from that moment on you can put whichever malware you want, whichever backdoor you want, and it's very likely that goes unnoticed. And of course the Pegasus that's became quite famous the past few months, and it's a big problem. It's a huge security problem for that matter. But they are a huge external menace, but we have the internal threats as well, and that would be the Google Service Framework, because we have this lawsuit that the district attorneys of the state of Arizona, they are moving against Google. They are suing Google over their predatory practice of user data collection. And it's interesting to watch here that we have an employee, a Google employee, confessing that he uses G-Free, his personal phone. It doesn't have Google at all. So it's quite interesting to see that the irony here. So we have talked a whole bunch of the external layers. Now we go back to the inner layers of the virtual machines. So here we have the KVM, that stands for Kernel Virtual Machine. It's actually a fork from QEMU, and it's a Linux kernel module that allows full virtualization. The fact that it's a kernel module, it makes the KVM extremely lightweight. It's almost magical as it runs very smoothly. And of course, we need to have hardware virtualization extensions enabled. And KVM we can virtualize for pretty much any other platforms like x86, 60-bit, RAM, PowerPC, and whatnot. It's also interesting to notice that the KVM is about its source code. It's much smaller than the Zen kernel, the Zen source code, or even VMware, because Zen is much more older, but its code base it's quite problematic. And one of the reasons that KVM has excellent performance is that its code is very tight. So we have QEMU, that's a large set of emulators. They define themselves as a set of generic emulators. They're normally used alongside a hypervisor, like it could be used KVM, it could use Zen, it could use pretty much anything else. It also works as a virtualizer in itself in application level, but in that case you won't have access to the hardware, otherwise the performance will be terrible. So that's why I think it's interesting to think KVM, QEMU, and LibVirt, they are pretty much like the Rolling Stones. We have the sum of the parts is smaller than the big picture. So we have this LibVirt that's an API for managing virtualization monitors, hypervisors. It's compatible with pretty much anything you like, KVM, Zen. It even can manage Linux containers, Hyper-V, and all of that. I borrowed this verbatim from a Debian developer that's João Heriberto Mota. The first time I heard about, I became interested in KVM and all that was after watching a talk of his. And the LibVirt, it provides a single control environment with its own unified commands for several virtualization systems. It means that you learn LibVirt commands, you learn how to deal with LibVirt, and you don't have to learn the bits and bytes of VirtualBox or Zen and QEMU. If QEMU has a large command line, whole bunch of parameters, it's hard to manage on our own. So LibVirt, it's magical because of that. Because we also learn all these commands you can use for pretty much anything. We have Virsh, that's short for virtual shell. That's the command line interface, and VirtManager, that's the graphical interface. That's what the VirtManager is what's going to be demonstrated here. All the configuration files from LibVirt, it's an XML file, and it can be manually edited. It's not recommended to do. You can, but you shouldn't, unless you know what you're doing, and also you refresh the services afterwards, because it's all correctly loaded in memory. And even though the focus here is this individual user, it's an important thing to notice for anyone who is interested to deploy this in their works and largest environments. The VMs that are in execution, they can be migrated to other hosts with minimal downtime. I have worked a long time with VMware when I worked at HSBC, and the managing interfaces for VMware, they were quite solid, and whatever LibVirt has to offer, in my opinion, it's superior to what I have seen in VMware. So let's talk a little bit about Gnome Boxes, and then we are going to the demo. So it's an intuitive and easy to use tool that's a good option for beginners or casual users. The LibVirt, it's quite complex. It has a whole bunch of all the little details to be managed. Casual users, they might be scared off by that, so Gnome Boxes might be an interesting solution for that. So we have Gnome Boxes that it's based on KVM and QEMU, and it uses as well the hardware virtualization extensions. There is this small command that gives a diagnosis of whether the machine can use KVM or not. So one thing that is important to note here is that whichever machines you created from Gnome Boxes, it's not managed by LibVirt. The LibVirt, QEMU and all that, those machines, they're going to be available at the system level, while machines from Gnome Boxes, they are stored on user level. So, but anyway, Gnome Boxes shares code with LibVirt. It's also possible to take snapshots. Gnome Boxes has support for that, and it's also possible to access VMs from remote hosts. I never actually tested it from two different hosts across the network when it comes to their virtual machines, but the documentation says it does work. The biggest problem for me is that the network configuration is quite limited. We don't have the flexibility, nowhere near as the LibVirt. It could use DNS mask. That's a suggestion. I don't know. I'm not a developer, but I suppose it could be a point to improve that could give more advanced users more options. So of course it's assumed that the KVM modules, they are installed. We need to have all the hardware drivers working. Of course, if the drivers are not correctly configured in the host, they are not going to be visible to the virtual machines. And we also need to set permissions for the user. Normally it comes configured when we install the whole software, but it's possible that we have to do it manually. In that case, you just need to place your regular user in the groups of KVM and QEMU, KVM and LibVirt inside ETC groups. So we also need to install a whole bunch of software. So here's the list. All the tests I have done were on Arch Linux host, so that's the software rather for Arch Linux. In Debian it will be slightly different, but it's pretty much the same thing. One thing I do know that's different, that's why I put here the tools, that's the name. We have to search ADK, it's the EFI development kit for the firmwares, low-level firmwares from Intel, and also here it's the packages QEMU and KVM, something like that. I'm not too sure. Anyway, just make sure that you have all this installed on your machine. So here I'm gonna stop the presentation. I'm gonna play a small video that then it should have that open. So here we are going to see GNOME boxes. I apologize for that. I should have done it a little bit larger. That's a lesson learned. My bad, guys. So here we have CPU is capable of virtualization. KVM module is correct, installed correctly. So we are all good to go. Sometimes the modules, the KVM modules, they are not installed correctly. So we need in that case we need to mode probe, and that's debugging. I'm not going to do with that, but you need to have these modules, KVM and whichever hardware you're using, Intel or otherwise. And it's always interesting to look into this file, to look into, of course, it starts saying if the virtualization flags, if they are there, if they are enabled, and there we see about the bugs I mentioned earlier, Meltdown and Spectre. Here I placed the whole list, so the whole software list for Arch Linux. And like I said, if you look into the logs, something doesn't work, probably you're missing some kind of package. You have to work, sometimes have to compile from source, I don't know. Either way, the executables should be there if you're going to make it work properly. Oh, that list, it applies both for GNOME boxes and LibVirt, of course. So an important keyboard shortcut to know is that it's the left, Control left and Alt left. It's a standard from VMware. I'm very used to that. VirtualBox users are different. You can have your own. I like to leave that as a default, because it's important to know which is this shortcut in particular, because when you open a virtual machine, it captures the keyboard and mouse input. So we are locked inside the virtual machine, and this shortcut places us back into the hosts. So we click here on the upper side. To create a new virtual machine. It can download automatically from source. We can have Debian, we can have Endless OS is quite an interesting system, but here I'm gonna run Tails because it's fun. We have always to set which is the operating system, even if you place unknown or generic. We can adjust memory, we can adjust resources. We're not going to use disk in this one, but anyway, we're going to talk about disks in a moment. This machine, it uses CBIOS. It's a full Libre implementation of BIOS firmware. And here we're going to take a look into the PXE, that's remote boot from network. It's interesting to notice that it comes from it works. It searches for DHCP, but it won't find because it's not configured in this particular network. So here we can see that we have this network address. So this one on the left is the machine IP, and this one is the host IP. But since we don't have configured infrastructure for network boot, it won't work. And another thing worth mentioning is this combination of 525400. That's the standard for MAC addresses for virtual machines. You can have any MAC address you like, but this is a reserved MAC address. No vendor issues MAC address on this address, on this range. So it won't work. The remote boot, of course. You have to play. And there we have it. It boots from user. Yay. Oh yeah. Right. And while the system is booting up, we are going to see some other things like disks. We can have two types of disks. We can have raw. We have raw disks. That's one type. We can use QCOW. We can use VMDK. And here we're going to use QCOW and raw just for simulation. I normally use QCOW because it supports snapshot, unlike raw. So here we are going to allocate a disk of 1 GB. Sometimes we are recommended to create these disks using the command dd. No, it's a bad idea because it will take a long time if it's a large disk. Instead, we use fallocate, so we can have a raw disk ready. Here I'm creating another QCOW disk. It has the same parameters as f allocation, so it will occupy all the space that it's needed, but it's not going to use it. If you're using it in production machines, it's recommended to do like that. We can have the image. We can see the informations of the image. If the disk has any snapshot, it will appear here with this command. It works as well in raw disks, but normally we'll just show the information. A raw disk, it can be mounted like any other physical device, but QCOW disk, it's a bit different. We need to use NBD to mount it. So we can format, we connect it as a NBD device, network block device. We can format, and from that moment on, we can treat it like any physical disk. If we have more partitions, it will appear as NBD3, P1, P2, P4, and so on. So to disconnect, to unmount, we unmount the device and then disconnect from NBD. Here I'm going to create an encrypted disk, a raw disk, that we're going to use when we boot Tails on LibVirt. So here are the commands and all that. It will run. It takes a little bit of time. Then it's a encrypted disk. Then it's going to be formatted. It has to be open, of course. And then we format, and it's good to use. Oops. So there it is. We have a Tails vault, and then we're going to echo DebConf 2021, so we can see on the other side. So it's unmounted, and you can see in the background that the Tails machine has booted, finally finished the booting. So we have Tails. This is more, this is rather for show. I'm going to boot Tails one more time when we run for LibVirt. One thing that I was searching. Oh no, sorry. Here we have we can customize the machines. We can remove the devices. We can manage the snapshots. We can manage the hardware resources and all that. But unfortunately, we don't have more network options to run. So let me go back to the presentation. So as I was saying, a snapshot is like taking a picture of the virtual machine. The current state it's saved on the host disk, and further modifications can be reverted easily. It's almost like a Control-Z for machines. You break machine, but then you type Control-Z, and it's all good back to as it was. So snapshots won't work on raw disks, only QCOW and VMDK disks. QCOW and VMDK disks, they are compatible amongst themselves. The one thing to notice is that I prefer to use QCOW, but for compatibility purposes, it might be interesting to use VMDK especially if you're using virtual machines from other hypervisors. So there are two types of snapshots. Internal and external. Internal, it's saved inside the same file of the disk. It means that the disk file will grow in time, and it has its advantages. It has disadvantages. And external snapshot, it's saved as separate files. The original disk is made read-only, and the modifications made from then on, they are saved in this separate file. One last thing about the internal is that we need to reconvert the disk. We can use a QEMU EMG and convert, and we copy the disk from when we don't use the space of the snapshot is not being used, so we recreate the disk without that the other snapshots. Virtual disks, they can support anything like LVM, Lux, RAID, and they should be treated as any other physical block device. So here there are the commands to mount and all that. Like I said, it's recommended to fully allocate disk space upon creation, because you create a small disk and then it grows in time. Performance will not be as good. It can lead to other problems. So if you can spare the space, it should be done, especially if you're not using it's not a disposable virtual machine. I've allocated to create the disks and the QEMU image. So in this architecture here, it's a little bit different from the other. Here we're going to talk about the networking in virtual machines. We can have several types of networking when it comes to LibVirt, but the most interesting, the ones that I like to talk about are these two. Here we have a bridge that is composed by a dummy interface and the physical machine. Any virtual machine that's connected to this network, it will be visible to the outer network, just like any other physical host. If we are using here any machines here, they are going to be on protected network, on an isolated network, but they can still go to the internet. One little bit of things about Docker. Docker, it can be used on the outside, and it can be used inside the virtual machine. So I'm not too familiar with Docker. I prefer virtual machines whenever it's possible, but I like the idea, and for whoever feels comfortable, it's a great tool to use. Normally, when we are building these networks, we should use these IP address ranges, because can have conflicts when it comes from different networks and all that. I like to make networks that use different ranges, so I look at the IP address and I know from which network it comes from. Normally, we use this network mask, be it /24 or 255. That will allow inside this network some 254 hosts. For domestic networks, more than sufficient normally. So the virtual machine, it uses bridges. A bridge, in this case, we have the IP address is in the Aussie model. It's the layer 3, and bridges, they are layer 2. So these bridges, they are created with the physical machine, and they with the physical interface, and they allow the virtual machine to be just like any other physical machine in the network. It will have its own IP address, of course, and we also may use network address translation, so we can create these isolated networks. Even though the network here, I'll demonstrate, it is NAT. It's a different. I made it pretty much on myself, because LibVirt, it may conflict with the configuration, so I prefer to do it on my own. In Portuguese, we call that gambiarra. So there is another type of networking here. It's called isolated host only. The nomenclature may vary, but what has to be understood here is that they don't use. They don't have access. They talk. They can see each other, but they don't go to the physical network, to the internet. This host IP, this host firewall is IP tables based. I'll show the rules I use. And network manager is another problem, because since we're talking about notebooks, I don't want to configure. I want to use Wi-Fi. I want to use VPN, and that's why I did as I did. But if you're using this on a desktop, on somewhere that only has physical network, it could be interesting to do otherwise. So LibVirt, it manages DNS mask instances. It creates one instance for each network interface. Normally, if you have a pre-existing DNS mask instance, it shouldn't conflict with those created by LibVirt normally, because the configuration files will be different. And if we're going to have network boot, here we are going to need remote storages. In this case, I use HTTP. So we're going to talk about some use cases for virtual machines here. Video games, of course, because most of my motivation to research emulation and virtualization and all that was to be able to play Nintendo and Atari and all that inside my computer, and then Windows games in Linux. All sorts of software development. You can have a host machine that is rather clean, and you can have all the JavaScript frameworks, Python, whatever, inside different machines that won't pollute, won't conflict with your host's configuration. Software packaging. Well, it's known that Debian there is a Debian developer that uses Arch Linux as its system to package software for Debian. I think it's very easy. And we can have testing. We can test ISO images from the network, be it the ISO images that from different systems we want to try do some distro hopping. We should. But we can also do ISO images of our own and put them on the PXE infrastructure and boot them from the network in the virtual machines. We can have also test environment for firmwares and systems made for mobile and embedded. OpenWRT. I normally test my configurations in virtual machines before I start testing on physical devices. So it's diminishes the chances that I break some device. Same goes for Lineage OS. But Lineage, I haven't come to fully master the process of creation, of image creation there. So, but I'll get there someday. And we can also have software-defined routers and networks, SDR, SDN. pfSense can be virtualized in this environment. I wanted to bring pfSense virtualized here. Unfortunately, I wasn't able to do it so that I could demonstrate. That's why we're going to see OpenWRT in machine instead. And also financial and banking applications. This one here is rather intended for the Brazilian public, but any person that lives in a city that can be mugged or something, we have to think about it, because we are becoming hostages of the applications that are tied to a single device. We are with these devices all the time. So I have my banking apps installed my cell phone, and then I go out and I get mugged, and then I get all my money transferred. Not good. I'll have a big trouble to prove to the bank that I was mugged. There are several cases that are complicated. So we need to think about virtual machines as a viable solution for this problem that financial industry are creating to us. And last but not least, we have an isolated execution environment for hostile software, be it Photoshop, be it Windows, be it whichever privative software, but also forensics. It's interesting to notice that some malwares, ransomwares, and other plagues, they have some internal functions that they can detect if they are running inside virtualized environments, and they refuse to execute. So it's a proof that we must, even so, we must have some place that we can analyze and dissect these little bugs. So the thing is that x86 virtualization, it can be used using 100 free software. I think that hardware vendors, I'm looking at you, ThinkPad, I think they should embrace more free software. They should open source whichever it's possible. I understand that there are business plans, but you should consider this. On the other hand, virtualized ARM, it requires UEFI firmwares. It's not it's not as transparent as it should be. Like I said, I didn't bring any ARM machine to demonstrate, because I don't fully master its usage. What could be improved, for that matter, in the ThinkPad, in the host? Well, it could use LibReboot, always LibReboot. It could use 100 native support, 100 native support as in Linux support for fingerprint reading. We need the T470 in order to enroll the fingerprint. I have to use a Windows machine. It's quite weird. So also we have audio devices hot plug. That part I suppose it could be a pulse audio problem, desktop environment problem, but when you're using DocStation and the hot plugging from the audio devices, it's complicated. I can never use Jitsi on DocStation, for instance. So it could be improved, and the DocStation has some closed source firmwares as well. So here I'm gonna break it again, and we are going to see the LibVirt execution. So VirtManager. Here we're going to create a new virtual machine, use manual install. We can use other options in there, but I'm going to use Tails again. If you're going to change the architecture, now it's time. We can set the memory as well. And here we're going to disable, we're going to configure storage later on. The machine is called Amnesic, and here we choose choosing the network I mentioned before. Here, even though it's an open, the LibVirt understands it as an open network, but it's not. Its default network is inactive. I tried to delete it in the past. I had a whole bunch of problems with that, so I just leave it. I just leave inactive. It doesn't bother me, so I can use my own network. So here we choose between the architecture, like I said, and we can choose the chipset. Damn it! Moving on. Network, and here we change the firmware. I use BIOS, but it could be used as UEFI. So we can set the topology, a different topology than the hosts, then the processor. We can set the boot order. It can use network, but we are going to use CD-ROM, and I'm gonna also attach the disk that I created on the other video, so you can see it from the inside. And here, since it's a raw disk, it could be interesting to set to cache none. So I'm going to establish the correct boot order. There's a tick on the left, so devices will be enabled. And you can have as well direct kernel boots. We choose a file from the host disk and init RAM if it's that the case, kernel arguments, and we are good to go. And never forget to apply the changes you do, so it will be taken into effect. So here are the IP table, and while the machine goes into execution, there's the IP tables rules. I will place them in the Git repo so we can use it. And it's interesting to note that we need to have rules on all the three tables: NAT table, the filter tables, besides whichever you have in filter tables. Normally we deal with that, and Mango as well. So the network manager, as I mentioned, we need to create to have the network from the boot to have it working. So here we create a dummy interface. We attach it to we create a bridge. Technically, it's a bridge, so we can have both the network address, the virtual network address, and the physical address as well. And here you can see the XML files for storage, for networking, for virtual machines themselves, and all that. They are on those folders. Right, so here we have the XML configuration. If you are going to have boot network, we're going to need to add some other parameters. Here there are those controls to see if they are auto started. This one in the middle, it refreshes the files you've created something before it started the services, and then you can create a whole bunch of different types of of storage. So here we have tails. We should always scale the image so it's better fitting. Whenever you're using tails, don't forget to set an administration password, because if it goes idle, it goes into screen lock. You will be locked to the outside. Nobody wants that. It's important noticing that we have shortcuts, keyboard shortcuts that must be that we need to use in virtual machines, but they will affect the host. So whenever we need to use Ctrl-Alt-Del or Ctrl-F, whatever, use this send key. GNOME has it as well, so we can have the keys run on the guest service, the guest machine, not the host. So here we have tails on. The one thing that I will demonstrate here is we're going to see the disk that I have created earlier. So sudo -i, so we can see. I couldn't make the zoom better, but it's here. That disk, we're going to open it. So there you go. It's the same disk and all that, created from the outside, accessible from the inside. We're all good. And the memory size of the machine. So here we're going to see how to boot, how to use network booting. I leave a dedicated machine for that because I have this infrastructure, and we can see we can use pretty much as anything. We see that's a virtual machine, blah blah blah. And here we are going to boot debmati. While it boots, it will take a while, of course. And then I'm going to run other machines here. But before I do, I'm going to show you the default configuration. It's no big deal. It uses infrastructure from the outside. The actual image is coming from my router. And here I'm going to talk about a little bit about OpenWRT. OpenWRT, if you get an image, an 64-bit image, you need to convert the image from raw to keycal. If you want to use VMDK, it's just as good. Here I use the fallocate command, and once you do that with the machine, you're good to go. You just plug it to an existing virtual machine, and it's good to boot. Don't forget to boot the QCal, not the EMG disk. So here I'm going to run an OpenWRT machine that's pre-configured, so you can see it's 64-bit. It's using another disk, and just for the fun of it, it uses Grub as well. What a surprise. So OpenWRT, it's a very lightweight system. You can have multiple machines in there. So sometimes for some people it could be difficult to deal with it. So when you start in a virtual machine, the console will not be immediately ready. When you see that there are no more messages from the boot, you type enter, and then you go into the console. So it has access to the internet and all that. It's interesting to notice that it uses OPKG, similar to Debian DPKG. Man, my mind started to getting buggy from speaking all that English. Well, I'm closing the machines and all that. So here I'm going to boot. I was going to boot Debian Seed, but I decided to use instead FreedomBox. While I was watching their presentation, I downloaded the image. It worked out of the box. I downloaded the image. I created I placed it into a virtual machine, and simply worked. The one thing about VirtualBox is that you need to access its web interface beforehand. Here I have already configured a user. You don't have a default user, nothing like that, but you have to figure out the IP address you can access from the host browser, and then you can open the web interface. So here I was trying to figure out which was the IP. Right, so there's the IP. A little bit of technical problems that I had. So here we have, just type the IP address and it will be shown. Yeah, it's a self-signed certificate, but you can trust it. So there you have FreedomBox. Here it's already configured, of course, like I said, but it will have a form where you can create your user, no problem at all. One last machine to be shown here is I made an Arch Linux version. It's free. It's fully free software, because I compiled the kernel. I installed the Libre firmwares, and it's not Parabola. Parabola is a different distribution. It has its own repos, but here I'm using one of my own. So Arch Linux can be 100% free software. That's some rough theme that I have created for LXDM. So here we are coming to an end to the presentation, to the virtual machine presentation. So a few thoughts to wrap things up. So future is in self-hosting and adversarial interoperability. We must have self-hosting. We can leave our data, our softwares, and everything in the hands of the big tech. We must have interoperability between services, so we don't have monopolies like Facebook going on. So this is a notion that I borrow from feminism. The girls always say, my body, my rules. So if our devices and our data, they are extensions of our body, my device, my data, my rules. Privacy and freedom for the users, transparency and accountability for the vendors. It's not that hard. So there's a Brazilian singer that was already deceased, Raul Seixas. He would, roughly translating his song, he would say, do it, sniff it, and force it. Do it, whichever you have to do in terms of software freedom. Sniff it. You must know what goes inside our devices, and force it, because if you don't force it, you're not going anywhere. So things that should be improved. We need more drivers and microcodes that should be Libre, even if we need to use reverse engineering. I dream of the day that we will have open source versions of NVIDIA and Broadcom software, like firmwares, drivers, and whatnot. So we need to be vigilant about the blobs, the binaries, that closed source stuff that we have either in the kernel or in the firmwares or in our applications. Even if Android is open source, most of the apps, things that Google run, they are not open source. We need to have right of repair. We must increase recycling. We must have a more sustainable supply chain. Programmed obsolescence, it's something that should not exist. Whoever wants to defend predatory capitalism, they can, but they cannot call it sustainable. Capitalism is not sustainable, and whatever it says it is, it's greenwashing, and it's wrong, plainly wrong. They are destroying the planet. So we need, last but not least, we need to create and cultivate communities for users and developers and make them more welcoming and inclusive. More welcoming as in how we treat each other, and inclusive in terms of diversity and all that. And we must think that multi-core SSD, LAN gigabit, Wi-Fi, that Wi-Fi 5 gigahertz, and USB 3, they are still decent parts of hardware. If you live in Latin America, they are the top of the line most of the time, and they will be around for a long time. So we need to master them. We need to have them all libre and free. So that's about it. We are going to. I'd like to thank the opportunity to speak here. Thanks to the Debian community and to all who have watched here. Here are the footnotes. I haven't translated to English yet, sorry, but I have this whole bibliography, so it can be searched. It will be sometime on the GitLab repo. And one last message: what do we say to the big god, to the god of death, or the big tech, which are pretty much the same thing? Not today. So free Assange, free Manning, free Snowden, and fora Bolsonaro. That's about it. So I'm leaving here, and we are going now to the Q&A. Thank you all.
Now.
Okay, many thanks. We are now open for questions. I will read the first few from the Etherpad. And here we are. So, first question, as soon as I find it. Right, question 1. VirtualBox has a very nice GUI and is very easy to use. Do we have any such GUIs on Debian for KVM?
Yes, we do. We have both GNOME Boxes, and we have LibVirt own graphical interface, this VirtManager. They both work quite well, even though they are a little bit different in between themselves, because GNOME Boxes, it's rather for the user, for the user, and LibVirt is more system-wide. It's on a level of system. That would be the greatest difference between them. But they both work. They are compatible. They run in Debian and all that.
Okay, the next 2 items seem to be comments. So, right, comment the first. Libre firmware is a nice goal, but as seen with by firmware, SOF designed, but probably not other areas as well, there might be a problem with hardware enforcing fixed set of cryptographic keys. I don't write them, I just relay them.
Yeah, well, about that, it's interesting to notice that all those cryptographic keys usage and hardware enforcing and all that, it depends mostly on what the vendor implements. So if the vendor, it's a political choice actually, because if the vendor decides to give the keys to Microsoft, we have to install either Windows to have cryptographic and signed and all the whole 9 yards. We could have that for the users. There are ways to have firmwares and cryptographic keys and all that. It's mostly up to the vendors. For instance, we have the hardware that I mentioned was ThinkPad. It's notebook that I use. I'm a big fan of ThinkPad hardware. And some models, they do work with LibreBoot. They don't have problems with firmwares and all that. But at the same time, there are more recent models that do have. So it's in the end, it's simply about the choices that the vendors make. The more vendors that are selling Linux, they see that it's working and all that, it's better. And From the moment that we have one Linux distro, be it Ubuntu or Debian or Arch, that have that are politically relevant to the vendors, we open this door for one Linux distro. All of them could enjoy it. So it's a rather complicated problem because it's not within our reach to solve it, most unfortunately.
Okay, we have one more comment on the Etherpad, which was a minor nitpick saying, one technicality about MAC addresses is that there are no duplicates on the same network.
Yeah, there shouldn't be. There might be, but normally, though, if you're talking about these MAC addresses from that are created from on virtual machines, they are supposed to be random. So you don't have to worry about setting the MAC address, and it will be generated and all that. The one thing that MAC address will be very useful, and I regretfully forgot to mention that during the talk, was that we can configure the DNS mask to attribute IP addresses based on MAC address, so we always know which IP we are using. That's a problem that I had in the presentation that when I booted the Fernao box, that I had to chase the IP in there.
Right. Are there any more questions from the audience? We'll just wait a few moments.
Apparently not.
Right. In that case, muito obrigada. Thank you very much.
You're welcome.
I guess we will have people join us for the next talk very shortly.
Okay, I thank you for your audience and for your patience. I know that the comment that is in there about my rant about cryptography, well, I perhaps overdid it, but I still felt it was necessary because, well, you all know why. But anyway, I'd like to thank you very much from the bottom of my heart. It has been great to do all this research and be here to share knowledge, and I hope it was enjoyable for you guys just as much as it was for me.
Okay, thanks very much.